Now we are going to discuss about parallel combination of resistors. What is the parallel combination of resistors? How to derive the mathematical equation for the parallel combination of resistors? Consider three resistors of their resistances R1, R2 and R3. This is the resistor of a resistance R1. Then we can take another resistor of its resistance R2. Then the third resistor of resistance R3. For these three resistors is the first terminal and is the second terminal. All the first terminals of three resistors, all the first terminals of three resistors, we can connect it to one common point. It has a P, and second terminals are connected to another common point of Q. Such combination of resistors is said to be parallel combination of resistors. All the first electrodes are the terminals of three resistors are connected one common point, and the second electrodes are connected to the another common point. Such combination of resistors are said to be parallel combination connected across through a cell or battery of its EMF E through a plug key K. Through a plug key K. So is the key K and battery B of potential V. Now in this is parallel combination of resistors, potential across by the resistors R1, R2 and R3 is remains constant because all these three resistors are connected. All the positive electrodes are a positive terminal of the cell, and second electrodes are connected to the negative terminal of the cell. That's why the potential in the circuit is remains constant. Potential V is equal to constant or same in the parallel combination. When we make the circuit, current I is passes through the circuit. Current I reaches to the junction P, then divide through the resistor R1 as an I1, resistor R2 as an I2, resistor R3 is an I3. I1, I2, I3 are the three currents. Divide at a junction P, passes through the resistors R1, R2 and R3. All these three currents passes through the resistors. Again they join at a junction Q and becomes a current I. Therefore, the total current in the circuit is remains constant. When the total current in the circuit remains constant, according to the law of conservation of a current or the charge, net current in the circuit I is equal to sum of individual currents through the resistors R1, R2, R3, that is I1, I2 and I3 can be written as I is equal to I1 plus I2 plus I3. This is net current through the circuit is equal to the algebraic sum of individual currents across by the resistors R1, R2 and R3 according to the Ohm's law. According to Ohm's law. When we consider the Ohm's law, that Ohm's law V is equal to IR. From this equation, I can make current I is a subject, then I is equal to, we can write V by R. This equation, current I is equal to V by R, we can apply for all the three resistors R1, R2, R3. Then we get current through the first resistor R1 is I1 is equal to V by R1. Current through the second resistor I2 is equal to V by R2. Current through the third resistor, we can get I3 is equal to V by R3. Then value of I1, I1, I2 and I3. These are the four values are substitute in equation 1, that as I is equal to I1 plus I2 plus I3, we get V by R is equal to V by R1 plus V by R2 plus V by R3. Then in RHS, V is the same, that's why V we can take common. That is V by R is equal to V into 1 by R1 plus 1 by R2 plus 1 by R3. V is the same in both sides, we can cancel it. Therefore, the resultant resistance in a parallel combination R is replaced as a RP, which is equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is the resultant resistance in a parallel combination. That means 1 by RP means reciprocal of a resultant resistance in parallel combination, which is equal to the sum of reciprocals of individual resistance of the resistors. Reciprocal of resultant resistance in parallel combination is equal to the sum of reciprocals of individual resistance in parallel combination. Therefore, 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is the resultant resistance in a parallel combination. When we know series and a parallel combination of a resistors, for example, we can take n resistors. Those n resistors we can connected in a parallel combination. For n resistors, for n resistors in parallel combination, 1 by R suffix P is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus and so on plus 1 by Rn. So this is an n times, because we can take n resistors in a parallel combination. These n resistors are identical. At that time, the resultant resistance in a parallel combination, we can write 1 by R suffix P is equal to n by R. From this, we can write resultant resistance for the parallel combination R suffix P is equal to R by n is the resultant resistance for n identical resistors. This is a parallel combination of resistors. For three resistors, 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. For n identical resistors, Rp is equal to R by n, or 1 by Rp is equal to n by R. For n resistors, 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus and so on plus 1 by Rn. This is the series and parallel combination of resistors. When we know series and parallel combination of resistors, We can take one application problem, then which is better to use for a series or a parallel combination. Consider an example problem. Consider two resistors of their resistances 1 ohm and 100 ohms are connected. One is in a series combination, second one is in a parallel combination. Then which is a better combination for the resistors? They are given two resistors. One is a 1 ohm of a resistance. Another one is an 100 ohms of a resistor. These two resistors are connected through a battery and a key connected in a series. Then what about the resultant resistance in a series combination? The resultant resistance in a series combination, Rs is equal to R1 plus R2. When we know the formula for the series combination of resistors, Rs is equal to R1 plus R2, that is equal to, they are given R1 is equal to 1 ohm and R2 is equal to 100 ohms. Then resultant resistance Rs is equal to 1 ohm plus 100 ohms, that is equal to 1 plus 100, 101 ohms. In series combination, the resultant resistance Rs is equal to 101 ohms. This is the resultant in series. Then go for the parallel combination of resistors. Is the first resistor of resistance 1 ohm and another resistor of resistance R2 is equal to 100 ohms. These both are connected in a parallel across a cell through the battery or key. When these are connected to the parallel, then what about the resultant resistance in a parallel combination? What about the resultant resistance in a parallel combination? In parallel combination, resultant resistance 1 by Rp is equal to 1 by R1 plus 1 by R2. From this equation, the resultant resistance in parallel combination of two resistors Rp is equal to, then take LCM and simplifying this, we get R1 R2 by R1 plus R2. Substitute the values, that is equal to R1 is a 1 into R2 is a 100 divided by 1 plus 100, which is equal to 1 into 100 100 by 1 plus 100 is a 101, which is equal to 100 by 101 is a recurring decimal, that is equal to 0.9999 and so on. It is a continuous 0.99 ohms. It should be considered as 0.9 ohms. Now you can observe in parallel combination, the resultant resistance we can get Rp is equal to 0.99 ohms, and then parallel combination we can get Rp is equal to 0.009 ohms. In a series combination, Rs is equal to 101 ohm. Then observe in these two values are the resultant values, which is a more in a series combination is a more than the parallel combination. That's why the resistors in parallel combination is more advantage than the series combination of the resistances. So that in our household all electric circuits we connected in parallel combination because we have to use the electrical resistor conducting wires. These all wires we can connected in parallel combination because they offer the small resistance, so that the resistance or the resistors are connected. Parallel combination is a more advantage than the series combination because in parallel combination they offered a very less resistance. That's why household electric circuits or hospital electric circuits or industrial electric circuits are connected in a parallel combination. Thank you.